Hi guys, how you doing? We're just going to go over 5.1 right here. And remember, this is 5.1 was a lot about simulations. The actual topic was randomness, probability, and simulation. So just defining probability and showing how to use a simulation to get a probability. Concept 1, the idea of probability. When we observe random behavior over a long series of repetitions, a useful tactic emerges. While random behavior is unpredictable in the short term, a regular and predictable pattern becomes evident in the long run. The law of large numbers tells us that we observe more and more repetitions of a random behavior. As we observe more and more repetitions of a random behavior, the proportion of times a specific outcome occurs will settle down around a single value. So that was like when I showed that applet before, and it was flipping a coin, but we did 10 flips. Sometimes you could get 2, sometimes you could get 7 or 8 tails. But if you're doing 1,000, then your actual amount of tails that you got was very, very close to 500. Okay, it got closer, and as you do more and more, if you got 10,000, very close to 50%, which would be 5,000, etc. Okay. So as you increase the actual, if you increase the number of repetitions of your random behavior, the proportion of times a specific outcome occurs will settle down to a single value. This long-term proportion is the probability of the outcome occurring. The probability of event is always described as a value between 0 and 1, where 0 represents an event that never occurs. 1 means that the event will occur on every repetition. All right, so let's do some of these. The probability of drawing a jack, queen, or king from a standard deck of playing cards is approximately 0.23. Explain what this probably means in the context of drawing from a deck of cards. Well, that means that right here, if we repeatedly draw cards from a standard deck, we will draw this is a draw right here, a jack, queen, or king about 23% of the time. Okay, just strictly random behavior. And notice I did say about 23% of the time. Okay, so again, if we repeatedly draw cards from a standard deck, we will draw a jack, queen, or king about 23% of the time, right? Something about like this. It doesn't have to be exactly how I wrote it. 2. Does this mean if we draw a card, replace it, shuffle, and draw 100 times that we will draw a jack, queen, or king 23 times? Why or why not? So are we always going to draw a jack, queen, or king exactly 23 times? No, probably not. Okay, we might, a couple times, but in general, probably not. This probability is not a guarantee. Chance behavior still comes into play. We will draw a jack, queen, or king about 23 times, right? If we do this 100, if we do a repeatedly draw cards 100 times, we will draw jack, queen, and king about 23 times, but it might be a little bit off from 23. Again, a probability is a long-term prediction. Okay. All right, all good. Let's go to the next section right here. In this section, we learn how we can use simulation to estimate the probability of an event occurring. A 3-step process can be used to perform a simulation of a question of interest. 1, describe how to use a random device to imitate a repetition of the random behavior. 2, perform many repetitions of the simulation. And 3, using the results of the simulation to answer the original question. So more specifically right there, what they're saying is, 1, you describe how to use a random device to imitate. That could be a table of random digits. That could be a random number generator. So right here, you want to label, and we'll talk about labeling in a second, and use a random device. So that's your step 1 of your simulation. Step 2 right here, perform many repetitions of this. So, if they're saying to come up with your own simulation, you come up with something that's many. That could be 50, 100 trials, whatever. So you do many repetitions. Part 3, you use those results of the simulation to answer the question. So use results to answer the question. Okay, so let's do that, do an actual simulation right now. Let's see. A popular airline knows that in general, 95% of individuals who purchase a ticket for a 10-seat commuter flight actually show up for the flight. In an effort to ensure a full flight, the airline sells 12 tickets for each flight. So there's only 10 seats, but they reserve right here, they're going to sell 12 tickets because they know that 5%, right, of people more than likely will not show up. We're going to design and carry out a simulation to estimate the probability that the flight will be overbooked. That is, more passengers show up than there are seats in the flight. Okay, so right here, let's do the first part, which is label right there. So our labeling is going to be like the 95% part, right? 95%, so 95 out of 100 are people that actually show up. The other 5 out of 100 are people that are not going to show up. And I'm going to use, I decided right here, I'm going to use a random number generator. That way I don't have to worry about the number of digits to deal with. Okay, it said I could pick whatever I want to. So I'm going to pick random number generator. So we're going to designate the numbers 1 to 95 as showing up. That means passengers show up to the flight. We're going to designate right here 96 to 100 as no-shows. Okay, so 1 to 95 are people that show up. 96 to 100 are no-shows. That means people that do not show up to the flight. We're then going to use a random number generator. Now, right here, we're saying right here 12 tickets. So we're going to generate 12 unique integers from 1 to 100. All right, now I already said the word unique, but I threw in here disregard repeats just as an extra. But as long as you say unique, it should be fine. Then we're going to count how many times the integers from 96 to 100 occur. Now, why are we doing that? Why do we care about 96 to 100? Well, those are my no-shows right here. So if I have 2 no-shows, then I'm good, right? That means that 10 people are actually going to get their seats. If I have more than 2, that's even better, right? Then there's extra seats on the plane, right? That means only 9 people are there. And there's only a 10-seat commuter flight, right? Now, what's the issue here? It's overbooked right here. So if we have 1 or no integers, so if we have 1 integer or no integers from 96 to 100, that means the flight is now overbooked. Okay, so that means that if we have 1 or no integers from 96 to 100, that means the flight is then overbooked. That means we have 11 of the showing up, or we could have the 12 of the showing up. So it's overbooked. All right, so, and then right here, we'll do this last step. Remember, we do many repetitions, so we're going to repeat this process 50 times. And that determines the number of overbookings out of 50. That will give us a probability. Okay? All right, so once again, right here, so our first part was labeling. We designate the numbers 1 to 95 as showing up, passengers showing up to the flight, and we'll designate 96 to 100 as no-shows, not showing up to the flight. So right here, as long as we have 2 or more no-shows, we're okay. But the problem arises if we have less than 2 no-shows. So we will use a random number generator to generate 12 unique integers from 1 to 100. We're disregarding repeats. We're going to count how many times the integers 96 to 100 occur. We have one or no integers from 96 to 100. The flight is overbooked. So we're going to repeat this process 50 times to determine the number of overbookings out of 50. All right, so that is it right there. So if I actually, let's say I was actually doing, this is just an extra thing here, but if I'm doing this process right here, so we're doing I would actually go to math, PRB, and then rand int right here. Now we're doing 1 to 100, right? So it's a 1, 100. And we're doing this process 12 times. So I'm going to put comma 12 right there. So this is going to generate 12 random integers from 1 to 100, right? So in this particular case right here, we're trying to count how many we have from 96 to 100. These are right here the no-shows. We have 1, 2, that's 98 right there. And we had a 96 to begin with. So we have 2. So in this case right here, we have 2. You don't have to do this again. I'm just showing you if they ask you to actually perform the simulation. So the first simulation we did 2, right? Now, we would do this 50 times, right? Kind of a pain, definitely. But, you know, they probably would just ask you, if they would ask this, they would ask you to just do a few of these right here. So in this case right here, it looks like we have 1. There's the 98. We have 2. We once again had 2 right here. So 2 is okay, right? So in this case right here, we have right here 0 out of 2 times that we had an overbooking. So far we're okay. We have, you know, and then you just would keep on doing it, etc. So that was kind of, if they ever asked you to do actually this simulation, this is what you would, this is kind of the process you would do, and you would just describe, you know, what you got right here. All right, guys, have a good day. I will hope you understand this okay, and I will see you soon.